Okay, as discussed today, this is the revision part of the today's topic, that is average velocity and instantaneous velocity. We will be using resolution of vector, that is the application of vector to resolve average velocity and instantaneous velocity in the x component and in the y component. Okay, similarly, we will be doing this for the instantaneous velocity. We will be resolving instantaneous velocity in the x component and in the y component. Okay, we already know what is the velocity. It is the displacement travel upon an interval of the time. And what about the instantaneous velocity? See, instantaneous velocity tells us about that at a particular instant, a particular time period, the displacement travel will be giving me the velocity at that particular point. Instant ka matlab kya? What is the definition of the instant? That at that time and at that point, the velocity we will be getting is the instantaneous velocity. And what about the average velocity? Average velocity is between 2 points. Okay, for example, if I want to go from Vapi to Surat, okay, if I want to go from Vapi to Surat, okay, nearly about 199 and 190 kilometer, okay, just tell me, does the train travel at the same velocity throughout that distance? No, the train may be at 50 kilometer at some point, 80 kilometer at some point, 70 kilometer at some point, but on an average between these 2 points, that is Vapi and Surat, okay, the train will be traveling with this velocity of 60 kilometer per hour. So that velocity which we are calculating is the average velocity. Okay, between 2 points, the velocity, whatever velocity we are calculating, between any 2 points, we will be getting the average velocity. And what about the instantaneous velocity? Instantaneous velocity tells us about that at a particular time, let's say at t equal to 1 second, at that t equal to 1 second, the displacement the object is doing, we will be getting the velocity at that point, and at that time will be instantaneous velocity. Okay, now we will be resolving average velocity and instantaneous velocity one by one. Okay, so the first procedure, okay, we will be drawing a dotted line on the x and y axis, and the length cut by that dotted line on the x axis will be indicating the x component of the velocity, and the dotted line cutting the y axis, the length which it has cut on the y axis will be giving the y component of the velocity. Okay, so okay, on drawing the dotted line, we are getting on the x-axis, that is Vx, that is the x component of the velocity, and we are getting Vy, which is the y component of this velocity. Okay, so we can write the average velocity in the form of the x component and y component as Vx plus Vy vector, where Vx, the magnitude part of this x component vector, is Vx cos theta I cap. Here I is nothing but the unit vector which is indicating the direction. Okay, this I vector is nothing but a unit vector. What does unit means? It means 1. This vector, unit vector, is having the magnitude of 1, and it has the direction which is facing along the x-axis. What about the J? J is another unit vector which has a magnitude of again 1, but it is facing in the y-axis. Okay, fine. Instantaneous velocity. The direction of the instantaneous velocity, remember one thing, the direction of instantaneous velocity will be always tangent to the point where we are calculating velocity. Okay, so instantaneous velocity, see, resolution we will be not doing for the instantaneous velocity, that's the tomorrow's topic. We will be just doing the definition of instantaneous velocity. The definition is like that if the time interval for which we are calculating velocity, if it approach 0, अगर टाइम इंटरवल जिसमें मैं वेलोसिटी कैलकुलेट कर रहा हूं अगर वो 0 तक पहुंच जाए, 0 ना हो, 0 तक पहुंचे, फॉर एग्जांपल 0.001, it is not 0 but it is approaching 0, so at that point, at that time, we will be getting velocity as instantaneous velocity, which is written as which is written as v is equal to limit delta t tends to 0 del r by del t. This limit is indicating what? This limit is limiting delta t to approach near to 0, not to becoming 0. This limit is what is the purpose of limit over here in this formula? This limit is limiting delta t not to approach the exact value of 0, but to near the 0. For example, 0.001 is near to 0, but it is not 0. Okay, so this is the function of the limit over here. Okay, so instantaneous velocity is given by the formula v is equal to limit of delta t tends to 0 and del r by del t, and the direction of this instantaneous velocity will be always tangent at that point where we are calculating velocity. Fine, everybody. Hope you have cleared this two things which we have discussed today, and thank you.